Question 19. The graph shows a velocity v meters per second of a rocket at time t seconds, and part A, we want to find an estimate for the rate of change of the velocity when t is 2. So that's there. Now the rate of change basically means that we need to find the gradient at that point. So we're going to draw a tangent at t is 2. Now this is where the estimate comes into it, because everyone's going to draw that tangent slightly differently. But as long as it touches the graph at that point, that's the best thing you can do. And then we need to find the gradient of that line. So I'm just going to find two nice coordinates. I may as well use the dot that I've done there, and then that's a fairly nice coordinate there. Make a triangle to find the gradient. That's gone up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's gone across by 1. So the rate of change of velocity is 11 meters per second. Find an estimate for the distance traveled by the rocket in the first 4 seconds. Use 4 strips of equal width. That gives you a hint on what to do, but we need to find the area under the graph between 0 and 4. So we need to split it into 4 strips. And then we need to work out the area of each trapezium and just add it together. So the important bits of information are these bits of each trapezium, the y values. So that one is 62, that one is 26, that one is 8, and then the first one is 1. Okay. So trapezium 1, which is the first one, so if we add all those together, we'll get 5. I can type it into my calculator. So 66 meters. So they're just working out the area of a trapezium. That's question 19. Right, question 20. So the beehive the number is decreasing, and it's decreasing exponentially. Basically that means that it's decreasing by the same multiplier every time. So there's a week 6 missing. So we would times 1200 by something to get week 6, and then times it by the same something to get week 7. So we would do the population in week 5 times by that multiplier twice, and that should equal 900. So solving that equation, that is our multiplier, √3/2, which is about 0.87. So it's roughly decreasing by 87% every time. How many b's were there at the start of week 2? So we just have to now work backwards. So we'd have week 2, and we times it by that multiplier, and we times it by, I'd sort of write it out. So 1, 2, 3 times to get what we had in week 5. So and then just work backwards. So at the start of week 2, there were 1,200 divided by our multiplier cubed, and 1,847 or 48, whatever you choose to round that to, but both answers would be absolutely fine. Right, question 21. So we've been given the area of a trapezium, and we need to find the value of k. So applying the formula, so we've got half of k plus 4 multiplied by the height, and that's equal to 5√6. So just simplify this a little bit, writing that as √3/2. Now I can use my calculator to divide 5√6 by √3, although this might not do it, but we'll see. So divide it by √3/2, and it gives us 10√2. So k plus 4 equals 10√2. So k is equal to 10√2, take away 4, is in the form that it wants.